Hello everyone, this is Suresh and welcome to another Google Cloud Lab session. So in this session we are going to look into the distributed training with Keras on the Google Cloud. So without any delay, let me start the lab. So you can go through the overview of what we are planning to do here. So we are going to look into the how the distribution strategy set the input pipeline in the Keras model and define the callbacks, train and evaluate the model. This is the learning objectives of this task, this lab session. Let me open it in the incognito window. Copy the password and the setup is already completed. This is what we did. So let me go to the setup environment, navigation menu, click Vertex AI and dashboard. Navigation menu, Vertex AI, dashboard, and enable all recommendations. You can see the notifications enables all the recommendations. Next, let me launch the workbench in Vertex AI. So in the Vertex AI, we have a workbench and user managed notebooks. Click on use, click create new. Let me rename this as workbench. I will select the TensorFlow Enterprise 2.6. I think this is old. Okay, before going that, let me select the region US East 4. Leave as US East 4 VA region to any associate. That is fine. Name the notebook is also done. So they are saying to create it. But here there are few more steps we have listed. Now you can see here the Enterprise 2.11 is available. However, but what the instructions is given to us is like to TensorFlow Enterprise 2.6. We don't have 2.6. I think Slab is old. So I will select 2.11 as the latest. That is the default we ever use. Rest of the things I will leave it as a common thing. Default is going to be E2 series with standard code. I will leave all the disks as default, networking as default settings, IAM and security in default settings, and system health the default. This will be created. So this creation will take about 2 to 3 minutes. So let's wait for 2 to 3 minutes and then get back. So this took about 2 to 3 minutes. So now you can see the status is active and you can see the open Jupyter Lab. So let me click on it. It's going to open in a new window, new tab. Task 2 is completed. Now moving on to task 3. Let's clone the repository, course repository. So click on the terminal and copy the command. So click on the terminal, the Jupyter Lab, and paste the copy command and click enter. Now you can see a folder will get created in the left side and also all the files will get downloaded. So let's wait to download all the files. So this is going to take about a minute or 2 seconds. So task 3 will get completed. Once we move on to task 4, let's navigate to this folder. Data set, data analyst, courses, machine learning, deep dive to production ML, training data set courses, machine learning, deep dive to production ML labs. Production ML labs. In the labs, Keras, can see, and open the Keras Python notebook. So let me open it. Now again, we have this notebook available for us to do some actions, some tasks. So what I will do is, as we mentioned, if we go to the array and clear all outputs. For the interest of the time, what I will do is I will open the solutions as well. That is also will be available in performance ML solutions. Let us open for our interest for the benefit of time. Okay. Now you can see. I hope that is the task 4, and that once we run all the code, all the cells, then that concludes our session. Let me go back here, go back to the notebook. So let me, you can pause the video at any point in time and go through this. This is the solution notebook I have created. So if you want to understand more about it, you can click on the link. You can download this repository, you can download to your local lab also. This repository you can download to the local lab and go through this location to open the file and go through the documentation if needed. Try to run in your local machine as well. That sometimes works. But I'm using Google Cloud so that I don't need to worry much about the infrastructure. So this is about all reduce. Just now I clicked about MPI all reduce concept. You can go through this reference as well. Also distribution strategy. The raw data. So to train the raw data we are able to see. So let me import the files first. You can see the kernel is busy, so we'll wait until the kernel will become idle so that all the imported will get. Now let's see the flow version that is 2.1. Download the data set, load the new this okay. So let me go to the solutions. For interest of time, I'm just copying this. This is the data set. So data set and info. This is the TensorFlow data set. Load mnist, go through as supervised true, mnist underscore train and test. So data sets will get trained and test. Enter. So now you can see there is 11 MB of data that got generated and so 100% is complete. Now create a mirrored strategy object with the context manager. Go to the solution. This is the strategy. Shift enter. Now strategy has been included. Now print number of devices that has been used in the strategy. It is going to be only one. Right? You can also do splits. At any point, you can pause the video and go through what is this GPU, what is the information provided. In this lab, I'm just executing the task provided to me. Apart from that, I'm not explaining about each and every line, or I'm not discussing the detailed concepts. Okay. In this cell, you can see there are a number of examples and number of test examples, the buffer size per replica, and the strategy. So pixel values which are we normalize it to 0 to 1. Okay. Basically feature scaling. Okay. Now scale the image and label for training. Now you can see we are doing map, cache, and shuffle for the training data set. And for evaluation data set, we are doing map and batch. So now we are creating a model which is going to be a Keras sequential model and conventional 2D, max pooling 2D, flattened, dense with activation of ReLU and dense of so 64 into so that many layers we will be able to see. And also you can see this, let me go here. So here we are compiling the model as well. So metrics we are going to calculate its accuracy and optimize it is Adam and sparse category cross entropy. So let's create the model. Shift enter. Define the checkpoint directly to store checkpoints. And also don't leave back as I'm doing. You can pause the video and go through, take the references and go through all uh, the keywords that you think that you want to be more knowledgeable in this area. Okay. There are a lot of trainings available over these courses are available, but my agenda in this is to only to execute the code that is provided in the Google Lab. Okay. Now here checkpoint directory, we are defining the checkpoint directory and also checkpoint files by using the epoch numbers. Okay. Function to decaying the learning rate. You can define decay function. Let's do that as well. Now callback from printing. Okay. Rate, print learning rate. Okay. Now callbacks that will have a tensor code, model checkpoint, and learning scheduler. Let's print. Now we are coming to the main work like training evaluating. So let's start with the training here. So we should be able to see 12 epochs as they provided here. So we have a training set, 12 epochs, and all the checkpoints needed for that. Let's see this. So let's wait to complete all that work. So this is going to take some time, and you can see the estimated time of action and also loss and accuracy over here. So you can see the learning rate for epoch 1 is 0.001 and the total 0.1 and the accuracy is 93, I mean 0.9399. Second epoch, there we can see more accuracy over here over the first one and the loss are also got reduced from 0.2 to 0.06. Okay. Third epoch, again the loss is very less than the second epoch and the accuracy has also got increased with the same learning rate. Much better accuracy at the 0.04, fourth epoch, and the learning rate is increased. Now you can see the learning rate. Better accuracy, the learning rate. Let's wait for all the 12 epochs to come. Now 10th epoch is going on. And you can see the variations here. Let me put it this way. You can see the from epoch 3 to 10, there is a increase in accuracy, and there is a decrease in loss, and also there is an increase in learning rate. I think epoch 11 is something happened here. That doesn't seem like, or there is some mistake. We should see 938, 37, 938. It is only 9. Something is happening. That's fine. We see some list of accuracies, and you can see the all the three, 1, 2, learning rate 9, learning rate 10, learning rate is increased, and also accuracy. If you can see, accuracy is almost same for 10. 11 is something different because I think that's 11 is somewhere it broke, I guess. 12 and 13 is same. So we have consistency. Oh, let's see the checkpoints. So this is the checkpoints and its indexes. And let's model the load weights, checkpoints, and also we calculate the evaluation loss and accuracy. So now you can see the evaluation loss is 0.03 and evaluation accuracy is 98.7. Let's go. See the output, you can download that output. Go to model. Let me copy the export to save model. Now, unreplicated models path. We have already provided the model saved model and compiling with the sparse categorical entropy, cross entropy, and optimizers used as Anna and accuracy. So let's evaluate the evaluation data set. You can see the loss is 3.3, whereas previously our loss is 0.38. Now you can compare this one with this one. Both are looking same. Fine. So we create the exact same model, including the weights and optimizers. So here we are recreating the models. We are compiling with the replicated model. Okay, now you can see the difference. Here we have created unreplicated model. Okay, whereas here we are creating with the replicated model. So now you can see the same evaluation loss with the same evaluation accuracy. Okay, so this mostly concludes our lab. This lab. So let me, okay, but anyway, you can download this files to your local system, then go through the links and learn more about it. So there are hundreds of courses available at online, so which you can go through in detail, in depth. But in this session, my intention is to only to complete the task provided in the Google app as they mentioned in the mentioned is the task. So this concludes my session. Have a great day. Take care.